Hey guys, in today's video we're going to be doing some vectors, and specifically how you can write an equation for a line which passes through two specific points. Now the general equation of a line which passes through 2 points is, we'll say L for line equals one of the points, in this case point A, plus k lots of the direction vector between the points. And so the direction vector is, in this case, between A and B, so it can be written like this: k lots of A to B. Now what A to B is in fact equal to B minus A, and I'm just going to show you quickly how we get that. So if we look at the diagram here, we've got an origin which is point 0, 0, 0, we've got point A 3, 1, 2, and point B 5, 6, 0. So if we say that this line here between O and A, which we can write like this, O to A, we've labelled as point A, as line A, and the line between O and B we have labelled as line B, travelling from O to B. You can see they have directions because they are vectors. So these are two lines we've already defined. So to go from A to B, like we've written here, A to B, we can see that we have to go down this line and along this line. So that would be minus A, since it's the A line but in the opposite direction, since we're travelling this way. So that would be minus A plus B. So we can say that A to B can be written as minus A plus B. And if we rearrange that, we can see that that makes B minus A, which is where this initial equation comes from. Okay guys, so now we know where this AB comes from, we can get on with the equation for the line itself. So we have our point A, and lambda, just in case you're wondering, I've changed it from k to lambda. It's just any number, it's a variable, so we can just put any sort of letter in front of it because it just denotes a random number. It doesn't have to be k, so that's what that is. But since we already know A, we just need to calculate AB, and like we just said, that equals B minus A, which in this case equals minus 5 minus 3, which is minus 8, 6 minus 1, which is 5, and 0 minus 2, which is minus 2. So that's our direction vector AB. So simply put, the line L is equal to A, which is 3, 1, 2, plus any amount of lambda lots of our direction vector AB, which is here, which is minus 8, 5, minus 2. And that, very simply, is the equation of a line passing through points A and B. And just quickly to explain why this works, is we start at point A, which is here, and what the second part is saying is that we can go any amount of this direction vector, which is this direction vector here. So if lambda was 1, we know that just makes A plus A to B, so we'd end up here. If lambda was a half, we'd end up around here. If lambda was 2, we'd end up somewhere down there. It just means that that equation can lead to a point anywhere along this dotted line. And so by being any point along the line and every point along the line, depending on what lambda is, it effectively means that that equation forms that whole line linking A and B and going on ad infinitum or for infinity.